Hi guys, in this video I'm going to go through microscopes. I'm going to go through the definition of what a microscope is, or actually what it does. And then there's two types of microscopes. There's a light microscope and an electron microscope. I'm going to go through what those are, and then we're going to go through the formula for magnification. So the first thing that we need to know is, what does a microscope actually do? So what does it allow us to see? And the answer is that it allows us to see things that we can't see with our eyes. So for example, if we see another human, we're not going to see the cells that they're made up of, are we? So cells, the subcellular structures, that is what microscopes allow us to see. So that's the first thing that we need to know. So what does a microscope actually allow us to do? Now, the first type of microscope is a light microscope. And we use light microscopes to form an image and to magnify it. And these microscopes use light and lenses to help us magnify into these specimens and to see the cells, for example. And these allow us to see larger subcellular structures. So, for example, nuclei. So that's the first type of microscope we need to know about. Now, the second type of microscope we need to know about is the electron microscope. And these microscopes are a little bit different because they don't use light and lenses to form an image. They use electrons instead. And this allows the image to have a higher magnification and a higher resolution. And just if you don't understand what resolution means, there is a definition of it. And that definition is that the degree of visible data. So an electron microscope just gives a sharper image. So sometimes it's much better to use electron microscopes. So there we have a definition of resolution as well. And I think that it's quite important to just know the definitions of these two microscopes and see what kind of things that they can allow us to see. So for example, an electron microscope, because it has a higher resolution and a higher magnification, it allows us to see smaller things, so even in more detail. For example, the internal structure of a mitochondria or chloroplasts. So we can see even tinier things like ribosomes and plasmids. So an electron microscope is really, it is good. So if you're looking at things like nuclei, we can use a light microscopes. And if you want to see in even more detail, we can use electron microscopes. So here are the things that we can see in more detail. These are just examples. There are lots and lots of other subcellular structures, the internal structures of things that we can see in plant and animal cells, even in bacteria cells. So those are the two types of microscopes and what they enable us to see. And now we're going to go through the formula for magnification. So here is the formula for magnification. And it says that magnification is equal to the image size over the real size. Now this might seem a little bit confusing, so let's just go through an example of a question and how to use this formula in that question. So here's the question. And it says that a specimen is 60 micrometers wide. Calculate the width of the image under a magnification of 50. So it multiplied by times 50. Give your answer in millimeters. Now the first thing we need to do is understand what the question is asking us to look for. So we've got the equation up here, the formula. And in the question, it's saying calculate the width of the image. So the image size. So let's underline that. So we need to find the image size. That means we need to rearrange the formula for image size first. So here we rearrange the formula, and it gives us image size is magnification multiplied by the real size. Now if we look here, all we've done is multiplied magnification by real size to get image size on its own. That's how we got to this formula. Okay, so now we've got the equation we need to work with. Let's underline the information that we have. So we've got 60 micrometers and we've got magnification of 50. So all we need to do is now plug in those values into this equation. So we've put in 50 multiplied by 60 because the magnification is 50 and the real size is 60 micrometers. So when we do that, we get an answer of 3000 micrometers. Now, that is the answer. However, it's asking us to give our final answer in millimeters. So when we convert that, we get 3 millimeters. Now all we've done here is we've just divided by 1000 to get micrometers into millimeters. Now there's another way we could do this exact same question, but in this step here, we've already converted the 60. Now micrometers, this here is equal to 10 to the power of minus 6. Yeah? So what we could do instead here is write 50 multiplied by 60 times 10 to the minus 6. And this is in meters. And we would get an answer of 3 times 10 to the minus 3 meters, which is in fact 3 millimeters. Now that's exactly the same thing, but all we've done is instead of leaving 60 on its own here, we've converted it into meters, and then we've gotten our answer. Now both of these are correct. Whichever way you feel easier working with, just do that. Yeah? So that was all about microscopes. If you like this video, give it a thumbs up. Thank you very much for watching.